Hey everyone, Sebastian here. Just wanted to let you know about this video. This is a compilation of Math Module 1 and Bluebook Test 4. If you've been following along, you know I'm releasing right now Bluebook Test 1 reading and writing questions one by one. I know eventually there'll be a compilation on that. And I've done Math Module 1 and Math Module 2B for the Bluebook Test 1. And this is Bluebook Test 4 because someone asked for them. I'm going to be doing Bluebook Test 4 Math Module 2B soon. And with the first math modules, I was releasing the solo questions first, but now I'm doing compilation and then solo. So I just want you all to know what's happening. Feel free to go watch Bluebook Test 1, watch the solo videos. These will be solo videos eventually too, just to have a more, relaxed feel, relaxed atmosphere. But you can watch this, grind them out in one sitting, or you can pause the video, come back when you want. So I hope you enjoy it, and if you have questions, let me know. All right, if x equals 7, what is the value of x plus 20? So x equals 7, so you just do 7 plus 20, right? Because x plus 20. And you have x equals 7, so you're going to plug that in. Boom. Right, and then you're going to get 27, right? So this one, about as easy as it gets on the SAT. Right, you wouldn't have to write this out. I'm just doing it to show everyone. But the only way I think you could make a mistake is if you read this as, if you thought in your head like x plus 7 equals 20 or something, and you got x equals 13, or you did some other silly thing like that. But really, this one's pretty straightforward. Data set x is 5, 9, 9, 13. Data set y is 5, 9, 9, 13, 27. The lists give the values in datasets x and y. Which statement correctly compares the mean of dataset x and the mean of dataset y? Okay. So I noticed, right, that they're all the same numbers except for that we have a 27 added on here, right? So, and that's the biggest number either of them have. So let's look. The mean of dataset x is greater than the mean of dataset y. The mean of dataset x is less than the mean of dataset y. The means of dataset x and y are equal. There's not enough information to compare the means. So this is automatically going to be, without doing any math, the mean of dataset x is less than the mean of dataset y. Why? Why is that, right? Because they have the same numbers, but this one has a 27 added on, and 27 is bigger than the mean. And how do I know it's bigger than the mean? Because the biggest number for 27 is 13. So you don't need to do the math, right? You could do, 5 plus 9 plus 9 plus 13, right? And find it, but that is a waste of time. That is just, don't do that. Please don't do what I'm doing right now. No, okay, so this is going to be over 4. No, we're not going to do that, right? If you wanted to do that, that's totally fine. That would give you the mean, but that is a bad idea. Don't do that because it's just wasting time. You have to, this is testing your understanding of it, right? It's understanding of how a mean works. And because we're adding a big number on, we're going to get a bigger mean for dataset y. So if you have any questions on this, let me know, right? The equation for dataset y would be the same, except you would add 27 to the top and make the 4 into a 5. But again, no need to do that. Really just read it, understand the concept, and you go from there. Right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18 degrees, what is the measure of angle S? Okay, so we have, these are right angles. We know they correspond because they see them and they're told that. Normally it's written in a way where each corresponding letter is in the same position too. And then angle Q is 18 degrees. So this is 18 degrees. Okay, and then that means that this is 18 degrees because they are similar. And then what does that mean S is, right? We're going to do 90 plus 18 plus S equals 180. I don't really think you need to write this out if you're doing this on a test, right? But I'm not in a rush here. I just want to show you all the work. 108 plus S equals 180. I'm going to subtract 108. Subtract 108. Again, you don't need to show this. S equals 72. All right. So that is the answer for this one. If you have any questions on it, let me know. It's just testing your corresponding parts. It makes it a lot easier that they drew it out for us. If they didn't draw it out, I would probably draw it out myself just to make sure I'm seeing where everything lines up. And if you do that, it's not too bad a question, right? So that's going to be B. A rocket contained 467,000 kilograms of propellant before launch. Exactly 21 seconds after launch, 362,105 kilograms of this propellant remained. On average, approximately how much propellant in kilograms did the rocket burn each second after launch? Okay, we got some math going on here today, right? So they want to find on average. That's often a code word for slope. And what we're going to do is we're going to take how much they burned. So this is how much has remained. So to find how much they burned, we're going to subtract and then divide it by the time, right? Because they want it per second. So 467,000. Again, this is a good calculator one. I'm just going to write it out for you all. 105 minus, right? That's going to be 104,895. And we're going to divide that by 21. You don't even need a calculator for this, honestly, because if you look at the answer choices, right, we have B, which is 17,000. 20 times 17,000 would be around 340,000. And then C and D are bigger. So you can plug it into a calculator and you get this number, but even without a calculator, you'll know that it's A, 4,995 kilograms per second. And that's how this one works, right? So the key really is to make sure you read the question carefully. If you had just done the math without dividing by the 21 seconds, you would have gotten D, right? B, I think, would be what would you get if you chose this number and divided it by 21 seconds. And C, I don't actually know how you would get C, but it doesn't matter because we're not getting C, we're getting A, all right? 4x equals 20, negative 3x plus y equals negative 7, okay? So normally I like to do elimination method, but here it's already eliminated. We can do 4x equals 20. We're going to divide everything by 4. We're going to get x equals 5. And then we can plug that in to the second part. We'll do negative 3 times 5 plus y equals negative 7. Negative 15 plus y equals negative 7. So y equals, what do we have here? What do we have here? Negative 7 plus 15. We're going to add 15, right? I should write that out. Is going to give us 8. Okay, and then we're going to do x plus y equals 5 plus 8 equals 13. Okay, so systems of equations can get more complicated, especially if one of them is nonlinear or quadratic, but in this one they're both linear, and one of them only had one variable. So we could just solve for that variable, plug it in, and go from there, and we get C. A certain apprentice has enrolled in 85 hours of training courses. The equation is 10x plus 15y equals 85 represents the situation, where x is the number of on-site training courses and y is the number of online training courses this apprentice has enrolled in. How many more hours does each online training course take than each on-site training course? Okay, so this is about reading this equation, right? We have 10x plus 15y equals 85. I'm going to rewrite it here to have some space to think about it with, right? So basically they're telling us that 85 is the number of hours, right? And these are the number of classes, X and Y. So if we're doing this, if you think about price, right? I think that's a more common way. If it was like something was $10 and something was $15 and the number of each adds up to 85, that's what's going on here, except instead of $10 and $15, it's 10 hours and 15 hours, right? And that would make sense, right? So let's say Y was 3, and X would then be 4, right? And that would get us 40 plus 45 hours equals 85 hours. So then that's just showing how 15 equals hours. 15 equals online hours. And and 10 equals on-site hours. And we know that because they say y is attached to the online and x is attached to the on-site per class, right? Per class. So then to find it, we would just do 15 minus 10 equals 5, okay? So this is kind of an abstract question that they sort of couch in a very simple, like, oh, what's the difference? But you just have to understand how to read it and what they're using it for, right? And once you have that, it's not too bad. Square x has a side length of 12 centimeters. The perimeter of square y is 2 times the perimeter of square x. What is the length in centimeters of one side of square y? Okay, so square x has a side length of 12. I'm just going to draw that out here. You know, I'm no Monet, but I can get it done here. I do what we need to. Perimeter of square y is 2 times the perimeter of square x, so that means each side length is 2 times. So y would be 24 equals y. This equals 12. What is the length in centimeters of one side of 24? Oh, look, I got it right there. D, right? So not too bad. The fact that it asks for perimeter, right? You could have done it the other way where you add up. You would do 12 times 4. That gets you 48. Then you do 48 times 2. That gets you 96. And then you do 96 divided by 4. And that gets you 24. But perimeter to side length is a 1-to-1 ratio. So if we're doubling the perimeter, we're doubling the side length. And we're going to get D. All right. So the given function G models the number of gallons of gasoline that remains from a full gas tank in a car after driving m miles. According to the model, about how many gallons of gasoline are used to drive each mile. Okay, so again, they're talking about each. When they're talking about each or per or the average, I'm usually thinking slope. If we look at this equation, right, it's very much a y equals mx plus b equation. So in that situation, right, y equals mx plus b, m is the slope. So from a full gas tank in a car after driving m miles, so that tells me that it's losing 1/20th of a gas tank, right, which is 0.05 per mile, and that would be A. Okay, so again, this one's not too bad. There's not really like computation that you have to do, any arithmetic. It's just about reading the formula. The SAT is really big on making sure you understand how to read functions, especially linear functions, okay? If absolute value 4x minus 4 equals 112, what is the positive value of x minus 1? Okay, so it's asking specifically for positive values, right? So let's try this out here. So when you have an absolute value, right, you have two formulas you make typically. So it's going to be the positive version, which is just a regular one. And then you're going to have one that equals the negative version, because the absolute value of the negative version would just be positive again anyway. So we're going to write the same part inside, but we're going to equal it to 112. And then this one here gets you 4x. When we add 4 equals 116. And then when we divide by 4, we're going to get 4 goes into 125 times. And then it goes into 16 4 times, so we're going to get 29. Over here, we're going to add 4 again, so we're going to get 4x equals negative 108, because we're going more positive, less negative. Divide that, that's going to get us x equals negative 27. But we didn't need to do that because it was just asking for the positive value. So it's going to be 29 minus 1, which equals 28. Now, another way you could do this is you see 4x minus 4 equals 112, and it's asking for x minus 1. So you could just do 4x minus 4 equals 112, and then you just divide by 4, everything across the board, and you're going to get x minus 1 equals 28. I am a big fan of those tricks, so I wanted to show you that. This time, honestly, it's all pretty square to me. It's all pretty even in terms of difficulty, but it's good to practice noticing the patterns, right? So try to notice those patterns in the future. Try to get to them before I get to them even. The given equation relates to positive numbers b, x, and y. Which equation correctly expresses x in terms of b and y? Okay, so we have x up here, b there, y there. So I'm just going to rewrite this so I can work with it, play around with it. 1 over 7b equals 11x over y. A lot of the questions you don't have to write out. This one I would write out. And I love questions where I have to write it out because it just feels like very productive. 7b times 11x is going to give me 77bx. 1 times y equals y. And then, it feels like I'm actually doing something when I have to do this. So I want x in terms of b and y. So I'm going to divide by 77b. And I'm going to get x equals y over 77b, which is c, right? So the other ones, if you got 77by, that would be sort of, you'd flipped the x and the y position. This one and this one, I think, are just thrown off, right? So if you understand how to do this question, that's great. You understand how to do proportions and ratio questions, right, with cross multiplying. And if you still have questions on it, that's also fine, right? That's why you're watching these videos, to get better, get stronger, learn your weaknesses, and make them strengths. The table shows 4 values of x and their corresponding values of f of x. There is a linear relationship between x and f of x that is defined by the equation f of x equals mx minus 28, where m is a constant. What is the value of m? Wow, they're so kind, they even made the value of the slope be m, like it normally is in our standard equation, right? So just asking for the slope, it's a linear relationship. So we just want to find the slope. The way we do that, right, is we do 2 points, right? So we're going to do y1 minus y2 over x1 minus x2 equals 137 minus 82. And you could do any 2 points. I usually just do the first 2 points because they're the first 2 I see. 15 minus 10. Normally you want to check if it's going to be the same as you go along, but because it tells us it's a linear relationship, we can just do it once and get it. So that's going to become 55 over 5, which equals 11. And now remember, the order doesn't matter, right? You could have made this y1 or this y1, but if you make this y1, you have to make the corresponding x value, the x1, right? That's all that matters. Otherwise, you might switch the sign on it. But this one is nice and clean, right? We just look at the values, plug in 2 into the equation, and we get 11. 5x cubed minus 3 minus negative 4x cubed plus 8. The given expression is equivalent to bx cubed minus 11, where b is a constant. What is the value of b? Okay. So I'm going to combine these first and see what we're dealing with there, right? So we got 5x cubed plus 4x cubed minus 3 minus 8. Right, we combine like terms, so this gets us 9x cubed. That's why I wrote them on one line, and this gets us negative 11. So we get 9x cubed minus 11 equals bx cubed minus 11. And now they have to be like terms, have to equal the like terms, right? So really the 11s anyways, they're going to go away because they're equal. And we get 9x cubed equals bx cubed. And then for these to be equal, right, b has to equal 9. You could divide out the x cubed. You could just think about it conceptually, and that will get us our answer, right? It's not too bad of a question. You just have to understand that you can sort of eliminate like terms and work on each like term on its own. The point x, comma 53 is a solution to the system of inequalities in the xy plane. Which of the following could be the value of x? Okay. So y is greater than 14, 4x plus y is less than 18. Let's see, which of the following could be the value of x? So we can plug in 53 for y and then solve for x, right? So we're going to get 4x plus 53 is less than, it's a bad less than sign, sorry about that, is less than 18. So you're going to subtract 53. The way I learned about less than signs was alligators. I wonder if you all learned that way too, where the alligator likes to eat the bigger number, right? So its mouth is open to the 18 because that's the bigger number here. So 4x is less than 18 minus 53 is negative 35. So x is less than negative 35 divided by 4. And that is going to be, if we want to get into a decimal, right, or a whole number, or a mixed number, right, negative 8.75. I know that looks like a comma, but it's a decimal. And that is A, right? Everything else is greater than that, so we're left with A. We plug in and try it, right? Negative 9, you get negative 36 plus 53 is less than 18, and that's true because that is 17 is less than 18. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? So it's doubling every 3 hours, and it's asking for 15 hours later. So how I think about it is how many units of 3 hours do we have in 15? The way I do find that is I do 15 divided by 3, which gets me 5. And then if it's doubling, right, we're just going to do 2 to the 5th. So it's going to be 2 to the 5th times the initial amount. I'm just going to write that as 300. Forget the 1,000 because they're all in thousands anyways. I'll just add on those zeros afterwards. And that should give us our answer. 2 to the 5th is 32. 32 times 300 equals something. And what does that equal? It's going to equal 9600. And then we're going to add on the 1,000. So it's going to be 9,600,000. And that is D, right? Not too bad, even though it's a nonlinear function. It's still pretty straightforward. If you remember, right, exponential functions have a function value like this. F of x equals, let's say, principal amount times, I would call this n to the x, right? So we just found x to be 5. N was the doubling, so that's 2. And then principal value was the 300,000, which I just put as 300 because the 1,000... I can just add on the zeros after because it's just multiplication. The graph gives the estimated number of catalogs, Y in thousands, a company sent to its customers at the end of each year, where X represents the number of years since the end of 1992. Where 0 is less than or equal to X, which is less than or equal to 10. Which statement is the best interpretation of the Y-intercept in this context? Okay, so we see the Y-intercept is here at 9. Okay, it has this sort of steady decline, right? It's nonlinear. So let's look at our options. The estimated total number of catalogs the company sent to its customers during the first 10 years was 9,000. Okay. The estimated total number of catalogs the company sent to its catalogs from the end of 1992 to the end of 2002 was 90. That doesn't fully make sense since we're talking about thousands and we're just talking about this value and X is in the years. The estimated number of catalogs the company sent to its customers at the end of 1992 was 9. And then the estimated number of catalogs the company sent to its customers at the end of 1992 was 9,000. Okay, so they tell us, right, that X represents the number of years and Y is the number of catalogs in thousands. So it's not going to be C because that's not thousands. It should be 9,000, and it's not going to be B because that's not thousands. So then we're between A and D, right? And only D makes sense because we're talking about the y-intercept, so that's when x equals 0. And what is the year when x equals 0? 1992, right? So that's like the beginning of this trend, is when they had 9,000. So A doesn't make sense. That'd be like the total. You know, if you know about integrals, it might have something to do with that, but it's not that one here. Which expression is equivalent to the 7th root of x to the 9, y to the 9, where x and y are positive? Okay. So I'm just going to rewrite it, and I see that it's in fraction form, so I'm going to rewrite it in fraction form. Remember, the root parts are the denominators of the fraction, and then the regular exponent of the numerator. So it's going to be x to the 9 over 7, y to the 9 over 7. And then you can just combine them and get xy both to the 9 over 7. And that's going to be b, right? So this one, very straightforward, not too much going on here. It's testing that you understand what we're doing with, roots and how they mean and how they can transfer into fractions of exponents, right? So it's not going to be 7/9, it's not going to be 7 plus 9, it's not going to be 7 times 9. That's where the 63 and 16 come from. The population of City A increased by 7% from 2015 to 2016. If the 2016 population is k times the 2015 population, what is the value of k? So it's a 7% increase, so it's not 7% of, right? So if we're going to be doing 7% increase, that would be, if we're writing it as a decimal form, 1 would be the original, and then we're going to add 7%. So it'll be 1.07, and that would be C, right? So I'm just going to show you, illustrated for you. So let's say in 2015, we had 100 people, right? Without even doing the math, let's just think about it intuitively. And we're told it's a 7% increase, so this is 2015. That means 107 was for 2016. And if you want to find k, right, because it's saying k is times the 2015 population, you would do 100. K equals 107. K equals 1.07 then, because you're going to divide by 100, and that gets us C, right? So this one, again, not too bad. You just want to be confident about what percents mean. You want to understand what the question's asking when it makes up this whole K thing. And it says K is 2015 times the population of 2015, So then we don't need actual numbers. If you're going to use numbers to sort of solidify it in your mind, I like 100 because it's easy to work with when we're talking about percents. And yeah, not a bad question at all. Which of the following systems of linear equations has no solution? Okay, so when we have no solution, we can think about it in two ways. We can think about graphically, right? No solution means there's two lines that are parallel, right? So they'll never touch. And we can think about, most things have one solution because they're two lines that sort of interact, right? But that's not what we're dealing with here. So two lines that are parallel, we can think about that graphically. And we can also think about it in the equation form, where we set them equal to each other, they cancel out, and there's two things that are left that aren't equal to each other. So in this, right, people sometimes will say, hey, plug this into Desmos. I don't want you to do that. We're not going to do it. I'm not going to do it. I'm not even going to show you how because it's not the way you should be doing this. It will just be more work than it deserves, because if we're looking at two lines that are parallel to each other, they have the same slope, but they have different y-intercepts, right? So let's see which of these have the same slope and different y-intercepts. X equals 3, y equals 5. Not at all what we're looking for, right? That would be sort of x equals 3 would be down like this, y equals 5 would be like this. They'd be perpendicular. Not what we want. Y equals 6x plus 6, y equals 5x plus 6. Those are not parallel, so they will cross at some point, right? They'll actually cross at 0, 6 because they have the same y-intercept. So not that one. And then we have C, y equals 16x plus 3, and y equals 16x plus 19. So if we had this one right, we're going to draw it out here. We'd have 16x plus 19. Let's say that's it, and 16x plus 3. That's a terrible, proportions. Would be something more like this. But again, they never cross because they have the same slope but different y-intercepts. That means they're parallel. So that is our answer because we're looking for something with no solution, right? And if we did D, we'd have a horizontal line at y equals 5, right? Something like that. And then we'd have 5x plus 5. So it intersects something like that. So again, do not use Desmos for this. Please understand the concept here, because Desmos is great for some questions. It makes some questions so fast, but here you're just wasting time. You should really understand what no solutions means, how it interacts with slope. If the equations were more complicated and you had to manipulate them to figure out the slopes, then okay, maybe use Desmos, but this one doesn't need that, so don't do it. The first term of a sequence is 9. each term after the first is 4 times the preceding term. If W represents the nth term of the sequence, which equation gives W in terms of 9? So there's a couple ways to think about this one. I'm going to write it out. Let's assume you didn't know how to do geometric sequences, right? So the first term is 9, the second term would be 36, right? So we look at the equations and plug in 1 for n. If we plug in 1 for the first, for a, right, we're going to get 4 times 9 to the 1, which equals 36, which is not what we want, right? Because we want it to be 9. If we do b, we'll get 4 times 9 to the 0, which will give us 4 times 1, which is 4, which is not what we want, because what do we want? That's right, we want 9. Yes, thank you. And then if we do c, 9 times 4 to the n, that's going to be 4 to the 1. That's going to be 9 times 4 again, which is 36 again. Again, not what we want, so it should be D. Let's check it. 9 times 4 to the n minus 1, so that's going to be 9. 4 to the 0 equals 9, okay? And that one works. That's the only one that works, so it should be D. It also makes sense in terms of the equation, right? Because we have the initial term here. Normally, the way we write the geometric sequences is something like, let's say, S equals n1 times the term value, right, which I'll just call R, the ratio, to the x, or something like that, right? So here, x minus 1, because we want to subtract away the first term to account for it. So to account for the fact that we have it right here. And that's what we want for this one. It makes sense, right? Because then we do the second term. If we did the second term, we'd do 4 to the 2 minus 1, which is 4 to the 1. And 4 times 9 is 36. So it makes sense for both terms. It's going to make sense for all the terms going forward. It's the best answer. It's the only answer. So the minimum value of x is 12 less than 6 times another number n. Which inequality shows the possible values of x? Okay, so minimum value, so that means x has to be greater than or equal to, because that's what the minimum means, right? X is greater than or equal to 12 less. 12 less than, that means you're going to subtract 12 from 6 times another number n. All right, if we look at this, right, it is going to be not A, because that's making x less than or equal to. Not C, because that's making it x less than or equal to. And then not D, because that's reversing the order of what we're subtracting, right? It's 12 less than 6n, not 6n less than 12. So we're left with B, which is the same as the equation we wrote down. And again, not too bad of a question. If you ask me, the side lengths of right triangle RST are given. Triangle RST is similar to triangle UVW, where S corresponds to V and T corresponds to W. What is the value of T? Okay. So we have these values RS, ST, TR, right? And based on the fact that TR is the longest, I can tell you S is the right angle because the longest side is the hypotenuse, and that's across from the right angle. So let's draw out a right triangle. Doesn't have to be perfect, right? We're not getting compared to Da Vinci or something. We just have to make sure we put the letters in the right place. S is the right angle, so RS is 20. ST is 48, and TR is 52. And then on the other one, right, we're going to have, it's going to be similar, so let's make it kind of look similar. They don't really, but same positions, right? So UVW, S and V correspond, so V goes here, and W and T corresponds. So W goes here, and then we have U up here, right? So now what is the value of tan W? So tan W is basically going to be opposite. So it'll be UV over VW, right? Because it's opposite over adjacent, right? Just a reminder, tan W equals opposite over adjacent. So then this equals tan W. Now, if you remember because they're similar, it doesn't actually matter what the values are here. It matters what the ratios are. And their ratios of sides are going to be the same as RST because they're similar, right? So we can just do tan W equals tan T. Tan T. And then tan W is going to be, okay, tan T equals RS over ST. And that's going to equal 20 over 48, which when we work to simplify it is going to be divided by 4, 5 over 12b, right? The graph of 9x minus 10y equals 19 is translated down 4 units in the xy plane. What is the x-coordinate of the x-intercept of the resulting graph? Okay, so when we talk about translations, right, translating down, that's a 4 shift down. So let's see we had something like, that's not what I wanted. You have a chart, a little graph, there's a line, and we're translating it 4 units down. So it's still the same slope, it's just down 4 units from the y-intercept, right? So there's a couple ways to do it, but what I would do is I would isolate y and then move everything down 4 by shifting down 4 on the y-intercept. So I'm going to subtract 9x and get negative 10y equals 19 minus 9x. And then I'm going to get y equals negative 19 10 plus 9/10 x, and then I'm going to shift down 4, so it's going to be negative 19 over 10 minus 4, and that 4 is going to become a 40 over 10, right, to give the same common denominator, and I'm going to get negative 59 over 10, that's right, whoops. So that'll be negative 5.9 for the y-intercept, right? But that's not what we want right now. We want the x-coordinate of the x-intercept. So how do we find the x-intercept again when y is 0? So now our new equation is going to be, I'm going to write this right here. Well, where did it go? There it is. Okay, y equals negative 59 over 10 plus 9/10 x, and then I'm going to do 0 equals negative 59 over 10 plus 9/10 x. To give myself some room, I'm going to erase some stuff. Okay, so now I'm going to add 59/10 to both sides. I'm going to have 59 over 10 equals 9/10 x. Then I'm going to multiply by 10/9, so that's going to get me 10 times 59 over 9 times 10. I'm going to close my 9 here. So that's going to be the 10s cancel. I'm going to get 59 over 9 is the x-coordinate at the x-intercept, and that is our answer, right? So I think probably the biggest mistake people will do is they'll write down the y-coordinate for the value, or some small mistake in terms of the calculations, but this question is not too bad. So I haven't done Desmos on this whole blue book, and this one I think people will be tempted to do. I was tempted to do it once too, but honestly, it doesn't work great because you have to isolate for y anyway and then shift down the 4, which is going to be the same work as I was just doing now. So I'll show you how to do it. So the thing I don't like about using Desmos here is that you can't just do 9x minus 10y equals 19, because the shift, how are you going to shift that, right? You can't just subtract 4 from 19 and get the shift we want, right? That doesn't work that way. What you need to do is plug in the equation we got when we've already divided it and isolated for y. So we could say f of x, right, equals, in place of y, I like f of x here, and I'm going to do 9/10 x minus 19 over 10, right? So that's the equation. And then to do the shift, I'm going to do f of x minus 4, and then I'll check the x-intercept, right, which would be 6.555 repeating, which is 59 over 9, which is what we got the other way, or it is, 6.555 repeating. You just cut it off. So this helps a little bit on the back end, right at the end, where you have to plug in and like move things down. It helps you keep track of that, but you still need to do the crucial step of isolating for y, right? So up to you which one you prefer. I kind of like doing the math old-fashioned way, but obviously Desmos can help some people here. But you can't fully depend on Desmos for this question, right? You need to understand that you need to isolate for y to be able to do the shift properly, right? Maybe there's some people have a different way of doing that, but if they do, I'd love to hear it. All right, so that's the video for today. That's Bluebook Test 4, Math Module 1. Pretty fun one. I think there were some good questions in there. I hope you found it all helpful. And I hope it's sunny where you are. And if it's windy, I hope the leaves are falling and twirling in the air, in a very cinematic and artistic way. And that they make nice designs on the ground. And I'll talk to you all soon. Bye.